In this video today, I'm going to go over the quiz 3 practice. So first question here says, for number 1 and 2, calculate the instantaneous slope and at the given value. Someone asked me yesterday, why do we put the x back in? Because instantaneous slope is slope at a point, right? That's why we put the x back in, okay? So I'm going to go ahead and write this. So this is going to be the limit as h approaches 0, right? So remember, what we're doing here is we're going to put our x plus h in for all of our x's initially and divide by h, right? That's our formula. So we're going to go 2 times x plus h squared minus 3, and then we're subtracting our function. So we're going to subtract the whole function, 2x squared minus 3, and we're putting all of that over our h. So now we're just going to start simplifying. So this is 2 times, sorry, I didn't mean to put that in black. Hold on. 2 times x squared plus 2xh plus h squared minus our 3. Then I'm just going to go ahead and apply that negative to minus 2x squared and plus 3. All still over our h. Now we're going to multiply everything that's in those parentheses by our 2. So this is going to be 2x squared plus 4xh plus 2h squared minus our 3 minus our 2x squared plus our 3 all over h again here. Now let's see what we can cancel out. So I see a 2x squared and a negative 2x squared. I see a negative 3 and a positive 3. Now I'm going to go ahead and simplify this. 4xh plus 2h squared, and that's all over h. So hopefully you know, we had a conversation about this a couple days ago in my class, where that this is really equal to 4xh over h plus 2h squared over h. You can break it apart, but what we're doing is this is the same thing because they have common denominators. So the h's there cancel out, and one of these h's cancel out, so that just ends up being h to the first. So this would end up being 4x plus 2h, right? And now we're going to rewrite our limit as h approaches 0. So that means we're going to put a 0 in for that right there, right? 2 times 0. So this would just be 4x. Now, when we're doing this, we got to plug this back in. It's instantaneous slope, right? So we cannot forget to do this, y'all, okay? So 4 times 2 is 8. So our answer here is 8, okay? All right, so this next one, again, we're going to write our limit. Our limit as h approaches 0. Again, x plus h squared minus 7 times x plus h. Okay, then we're subtracting that whole function. So that's going to be x squared minus 7, right? All over our h here. So again, this is going to be x squared plus 2xh plus h squared minus 7x minus 7h minus x squared plus 7. All over our h. Going to reduce or eliminate some stuff again. We got our x squared here and an x squared there. I've got, I forgot the x up there, y'all. Saw another error, right? So there's an x right there, right? And you know, sometimes when you guys start to see these patterns, you'll realize that obviously something's wrong, right? Okay, so that's going to be 7x. This is 7x, right? So that was what I was missing. So I noticed there's a negative 7x there and a positive 7x there. So some things should be eliminated. And there's, again, you should see some patterns emerging here. So once again, we got a 2xh plus h squared minus 7h all over our h, right? So we're going to simplify some of these h's. So this is going to be 2x. This is going to be plus h. And this is going to be minus 7. Now we're going to do our limit as h approaches 0. So that means this number right now is a 0, right? So this is going to end up being 2x minus 7. And then we're going to plug in that negative 3 in there, right? So we're going to say 2 times negative 3, which is negative 6 minus 7. So this answer is going to be negative 13. Answer was 8. Okay. This one says find the derivative. So this is the same thing we've been doing, right? So this is going to be the limit as h approaches 0 of 6 times x plus h plus 1 minus our 6x plus 1 all over h. So this is going to be 6x plus 6h plus 1 minus 6x minus 1 all over our h. So let's see what cancels out. Now we got a 6x and a negative 6x, right? We've got a 1 and a negative 1. And then when we divide that 6h by, so when we divide 6h by h, we just get 6. And that is the answer. Okay, let's do this last one over here of these. So here again, we're going to do the limit as h approaches 0, okay, of 4 times x plus h squared minus 5 times x plus h minus the 4x squared minus 5x, okay, all over h again. So this is going to be 4 times x squared plus 2xh plus h squared minus 5x minus 5h minus 4x squared plus 5x, just applying those negatives there, over h. Now I'm just going to multiply 4 times all this stuff. 4x squared plus 8xh plus 4h squared minus 5x minus 5h minus 4x squared plus 5x, all of this over our h, okay? So I'm seeing some things that are going to cancel out. 4x squared, negative 4x squared, right there. Then we've got our negative 5x and a 5x. So then I got 8xh plus 4h squared minus 5h, all over our h. So again, we're simplifying, right? So this is going to be 8x. This is going to be plus 4h. And this is going to be minus 5. Now we're going to do our limit as h approaches 0. So once again, that's going to make this guy right here 4 times 0. So that's going to go away. So this is going to be 8x minus 5. Okay, so I notice right here there's a hole. So x equals 0. That means this is what? Removable. That's the type of continuity. Discontinuity, sorry. And here, what do we have? We have a jump, right? So at x equals 3, we have a jump. Now, I don't know whether I put this on the key right or wrong, y'all, but only when the graphs go up and down. So if we had something here like this and then something also here like this, that's when it would be infinite, okay? All right, so the next one is x equals negative 2. Right here, what do we have? X equals negative 2. This is again a jump, right? And then over here, right there, x equals 1, we have a removable. Okay? All right, for this next one, it says identify the type of discontinuity given the expression and where it occurs. So there is no discontinuity here because this is just an equation, right? I mean, if there's no denominator, y'all, there's typically not going to be any kind of discontinuity, okay? All right, so on this, we're going to factor the numerator. So this is going to be x minus 6 and x plus 5. And then this is going to be x plus 5. Sorry, x minus 5. I'm going to do x minus 5. X minus 5 over x plus 5. So we notice here these cross out, so that would be x is equal to -5, that's going to be removable, right? Because that's where a hole would be, right? Okay. Then notice we still got this guy down here. And this is going to be our infinite, right? So this is going to be x equals 5, and this one's going to be infinite because it is a vertical asymptote. Remember, if you have anything left in the denominator, it's going to be a vertical asymptote, and thus it's going to be infinite there. All right, so number 9 says use the table to answer these. So the limit as x approaches 7 from the negative direction, so we're talking about going here, right? Isn't this 2? And the limit as x approaches 7 from the positive side, remember these are all positive numbers, these are all negative numbers over here. And this one's going to be equal to, so that was approaching 2 there, this one's approaching 3 there. Then it says, does the limit of x approaches 7 exist? The answer is no, because they don't approach the same number from both sides. From both the negative and positive sides. Okay. All right, so number 10 says use the graph to answer these questions. So what is the limit of f(x) as x approaches -2 from the positive side? So -2 from the positive side right there, that would be 0, right? Okay, then it says what is the limit of f(x) as x approaches 3? So as we're approaching 3, there's 3 right there. So what is it approaching on both sides? That is just 1, right? Then it says what values of c make the statement true where the limit of x approaches c, f of x equal to 0. So we're trying to find what values is it going to cross here. That's what we're really looking for, okay? What values there, okay? So when we answer this question, obviously, where x is equal to -4, right here, right? Okay. Then we could also say as x approaches -2 from the positive side, that would be another answer, right? And then also what? As x approaches 2 from both sides. Got it? Okay.